Okay, so today is chords. That is what we are doing. Carson actually accidentally drew a chord on the circle a few minutes ago. Okay, let me erase some of this because apparently this was last class. Okay, grab a washer if you would like. Okay, go ahead, draw a circle on your sheet of paper. Oops. Vincent, give it to Tioti. Okay, I have a circle. And I'm going to connect any line segment to 2 points on the circle. Doesn't have to go through the radius, doesn't have to go through the center, it does not have to be a radius. It's just a line that hits 2 endpoints on my circle. This point, this line is called a chord. This line is a chord. The chord is a segment whose endpoints are on the circle. It's the whole definition of a chord. We were actually drawing chords a little bit earlier when we were doing segments and find the area of segments. We had to draw a chord to get that segment. Okay, let's do an example with these chords. I'm going to draw another circle down below. And this time, I'm going to draw two chords. Draw one over here and one over here. Then I'm also going to draw 4 radius to each endpoint of my chords. Now I'm going to give you the fact that these chords are already congruent to each other. Now this chord and these two radius made what shape? Just get into that. Yep. So they're also congruent. So we know that all of these are congruent. So what can you tell me about these two triangles? Yep. Go ahead, Ashley. These will be, yes, isosceles. True. And they are also congruent to each other. So we have side, side, side congruency. So we know that these are all equal to each other. Congruent. Okay, now what if I didn't start with the fact that your chords were congruent? Let's say I start with the fact that the angles between the radius are congruent. So I'm going to draw my radius again. And actually, it's going to be like more like 2 diameters at this point. And crossing my toes that this was congruent to all the other radii in the circle. Now I have to get the fact that these blue lines are congruent to each other. I know they don't really look like it, but I just drew it poorly. Yeah, what angle, Carson? What's another name for those angles? I think I know what you're talking about. Starts with a V. Wait, which angles are you talking about? Tell me when to stop. These two? Sure. So if I did that, it would be, so this would be angle, angle, side, or angle, side, side. Can we prove triangles by this? I can also tell you that this angle right here and these two angles are what type of angles? Vertical angles. So those two are congruent. So by side, angle, side, these two triangles are congruent. Two triangles are congruent. So by CPC, do you know what that stands for? So close. Congruent parts of congruent triangles are congruent. All the C's mean congruent. So since these two triangles are congruent, then I can say that these chords right here are also congruent to each other. Great. That is the same theorem, but it's just the converse of its theorem as well. So 10.3 plus its converse. So it says if two chords in a circle, and this is going to happen a lot, I'm going to put parentheses and say or in congruent circles. So it might be in the same circle or it might be two different congruent circles in a situation. So if two chords are congruent, then their central angles, which are these vertical angles, are congruent. And this is an if and only if. So we have double arrows going. Do you want to draw another picture for this? Or are you good with the two above? Okay, let's just label these. Let's call this A, call this B, let's call this C and D, and we'll call this center point right here P. So this is saying if AB is congruent to CD, then it's an if and only if, so double arrows, then we know that angle APB, so that's right where the radius, both radii touch the center, is going to be congruent to angle CPD. And it can go both ways because it's a converse. Okay, next theorem. We're going to do a lot of theorems. They're just going to come at you fast. 10.4 plus its converse. Okay, this one's a little bit easier. Let's start by drawing a circle. Oh my gosh. Do you know that algebra and geometry are doing circles right now? And also pre-calc. So I spend the whole day just drawing circles on this thing, and it gets worse and worse each day. Well, maybe a little bit better, but okay. Drawing a circle. And I'm talking about chords all day today, so let's draw two chords. Ooh. 1 and 2. So I draw these chords, and we find out that the arc of these two chords are congruent. So the arc is right here. So if this arc and this arc are congruent, guess what's also congruent? Chords. Yep. Chords are also congruent themselves. And it's a converse, so it goes both ways. Ashley, how would you state the converse of this? That's the theorem, yes. And the converse would be the other way. So then the converse would be like if the two chords are congruent, then the arcs are congruent themselves. So if two chords in a circle, or, so in parentheses again, or in congruent circles, are congruent, and this is an if and only if, so the double arrow, then the arcs are congruent. Okay, that's actually the converse of this statement. So I just showed you the converse. This is the converse. Carson, can you give me this in terms of the A, B, C, D? Mm-hmm. Yep. And I denote that by doing a big, like, half circle up above. Is congruent to C, B. And I'm making this arc annoyingly obvious, but you don't have to be that obvious with it. I would just do a nice hump, but it has to be not a straight line. It has to be clear, not a straight line. Okay. Easy one, right? Another theorem. Chords are congruent. The arches are congruent as well. Okay. I'm running out of room. We are going to do one more and then do boards. Okay? Cool. I'm going to go up and scooch over. And, well, that's it. But we're going to erase it for a second. So pretend you all didn't just see this. But theorem 10.1 plus its converse. Okay. Let's start by drawing our circles. Actually, let's start with a statement. I'm going to start with a statement this time. So if two chords, Jody, you got it? If two chords. So if two chords are equidistant, have we talked about this word? Yeah, Lily, what does it mean? What do we think it means? It just means equal distance. Do I know why they want to shove it into one word? No. I don't like it. We could have just kept this if two chords are equal distance apart. They just didn't want to write that. So equal a distance. I don't know. Equal distance. I would just say that. From the center. And then our parentheses again. Or center of a congruent circle. And again, converse. So let's do a if and only if symbol. So double arrows. Then the chords are congruent. Now, the picture in this is a little weird. So let's start with our circles. Oops. It's really important that we match up our circles the same in our drawings. Okay, I'm gonna draw myself 2 quads. One like this, and one like so. So these are my 2 quads. Let's label it A, B, C, D, and my center point will be P. Now, to denote that they're 2 equal a distance away from each other, we're going to draw these pink lines. These are not radii. They're just saying that they are equal distance apart. These 2 lines are going to be the same. And they are the shortest line to get to my chords. These short lines that show that they're equal distance away always will make 90-degree angles. They make 90-degree angles. So make 90-degree angles. So I'm going to label where they intersect at E and F. So my theorem is saying that if EP, so that pink line, is congruent to the other pink line, so FP, this is going to tell us, so if and only if, then AB, that chord will be congruent to CD. And then Camille, how would I say the converse of this? You can just write it like that, or say it like that. Mm-hmm. Mm-hmm. Yeah, perfect. FP. Cool. Okay, we're gonna learn a little bit more about this theorem up on the boards. What? We were in 3 groups? Okay. We're gonna combine into 4 groups. Not 4 groups. We're gonna combine into 2 groups. Yeah, exactly. What, 2 people in each group? Not even. Okay, get up in your groups on the board, because I already got your groups. Then we're gonna switch it up. Who's in what group? Because I already forgot. Okay. Who else is in a group? Go over to your group. Actually, join our group. Vincent, join this group. Okay. Okay. I will give you your problem up on the board in a second. It's gonna take me a second to draw this. Let's actually all draw it together, because you're also gonna want to draw this up on the board. Okay. Our example is this. You can watch it. It's right there also. Oh. Except the answer is also there, so don't look at the answer. We have a circle. We always have a circle. I'm so sick of circles. I show them all day. That was
can't use the
good. No, because it moves and it slides and it comes out. It's too big for like the screen. So we have a chord right there. Let's call this R and S, and another chord over here called U T. And then these equal distant lines I'm going to give you to the length of 4. And what can I add to this since I've told you these are equal or distant lines? Okay, yep, congruent marks. And what else? What's in red? 90 degrees. That didn't look like 90 degrees, but that is 100% 90 degrees and 90 degrees. Okay, I'm going to give you one more line. I'm going to tell you the radius of this, and I'm going to be annoying and put it down there. This is going to be 5.5. So radius is 5.5. And I'm going to give you another fact. RS, the arc of RS, is congruent to the arc of UT. And I want you to find the length of RS and UT. You got it. What's the question? I want you to find the length of both chords. You can do it.
Oh, wait,
I know
got
you
it.
can. Yes.
Okay. So this is a triangle.
You know what? Drew can listen to all of you.
Oh, hello.
It's okay. I'll pause it.
So we could just do Pythagorean. Wait, no, we can't.
How do I pause this? Record. We are not done recording. Okay. So, what did we find out? What new fun fact did we learn in this problem? Yes. So EP bisects AB, and that FP bisects DC. So that tells us that this is congruent to that. That is congruent to that. And for Drew on this video, I'll tell you the answer for this one is 7.54 for both of these lengths. They should be the same. Cool. I'll keep that up there. Okay. We have one more theorem for the day. Last one. And this one is actually very, very important. So theorem 10.6 plus its converse still. Okay, I'm scooching down. I'll start you off by giving you the theorem. Do you like the picture or the theorem first? Theorem? Okay, let's start with the theorem. So if a diameter or radius, but you're mostly going to see diameter or radius, is perpendicular to a chord, guys, it's kind of what we just learned, is perpendicular to a chord, then it bisects the chord and arc. So it's kind of what we learned above, except they weren't talking about diameter and radius. They were just talking about the equal distance. Okay, now let's draw our circle. Boom, sort of. Okay, I'm going to draw a diameter. I'm drawing it straight. Boom. There's my diameter. And if they are being bisected, then they also have to be perpendicular to each other. Go ahead, pick it up, Tootie. Go ahead. I'll wait. I'm going to have to draw a chord. Right across. Like so. So if they are perpendicular to each other, what type of angles do we form? 90-degree angles. So these are all 90-degree angles right there. And if it bisects the chord, and it bisects the arch. So you know these fun facts. Let's add some labels. Let's call this A, B for our chord. Put C for that middle. Let's call this P, and this point down here, D. Okay, so this is saying that if CD, our diameter, is perpendicular to which line, Vincent? Yep, AB. And this is an if and only if, so double arrow. Then we know two things are congruent. What are two things? Camille, what's one of them? Oh, I'm gonna have to label this. Let's call that X. Okay. Yep, AX is congruent to BX. And, Raylene, what's the other thing that's congruent? So I know that it bisects the chords, so they are congruent, and it also bisects the arc. Yeah, so what are the arc? Yeah, and we do BC. And BC are also congruent. And then, for some reason, they have decided to give you another theorem that you probably already know. So we're going to write it tiny, because it doesn't really give us much info. I forgot there was another one. The perpendicular bisector of a chord contains the center of the circle. Now, does the radius contain the center of the circle? Do we have to touch the center of the circle to draw a radius? Do we have to draw the center of the circle to... No. Do we have to touch the center of the circle when we draw a diameter? Yeah. So that's just the theorem saying it has to be radius to diameter, which they stated right above, but that was theorem 10.7. It's kind of already implied in 10.6, so it's not much more information. So that's why we wrote it really small. Okay, we have 5 minutes. Yeah, okay, cool. So homework problems. Homework problems. 10.3, page 446, 18 to 21, and then 23 to 26. So it's 8 problems. And you can start it now, or we can start board work and you can ask me questions before you start doing it for homework. Okay, vote. Close your eyes. Your choices are start homework now, we have 5 minutes, or you can start board work, which is going to be very close to your homework, and you can ask me questions. So, hands up for doing homework now. Okay, hands down, and do you want to do board work now to ask me questions? Hands up. Okay, hands down. Okay, you guys can start on homework. 4 of you said homework. So, that's what we're doing.